convert the following linear system to an equivalent or to the equivalent augmented matrix, and then solve the system. So here we go. We want to convert this system to its augmented matrix. So we just need the coefficients of our variables. I'm going to line this right up underneath. So looking at the coefficients, we have 1, 2, 4 in our first column. The second column, we have 2, 4, 5. And our third column of the coefficient matrix is 4, 5, 4. Now the equal symbol, we do a dotted line. I want you to note that the textbook doesn't use a dotted line at all, so just be careful. I'm incorporating the dotted line. I think it helps to keep things more clear, but just keep that in mind as you read through the sections. And on the right-hand side of our dotted line, we have the constants, -8, -10, -11. Okie dokie. So we now want to take this augmented matrix and row reduce it to row reduced echelon form. So we want to row reduce the augmented matrix to row reduced echelon form to find the solution. So we are starting here with our first pivot, which is 1. Hooray. And let's use it to eliminate the entries below it. So we need to do two things. We're going to need to multiply the first row by -2 and add this to the second row to attain the new second row. And now we're also going to need to eliminate that 4. So the second thing that we're going to need to do is multiply the first row by -4 and add this to the third row to attain the new and reduced third row. So here we go. This is going to leave us with the equivalent augmented matrix. Now the first row remains as it is. That's still going to be 1, 2, 4, -8. And now let's think about step 1 here. We are multiplying the first row by -2 and then adding it to the second row. So we have -2 plus 2 leaves us with 0. We have -4 plus 4 leaves us with 0. We have -8 plus 5 leaves us with -3. And last but not least, we're going to have 16 minus 10, which leaves us with 6. So now we want to do the same thing, but this time we're going to multiply the first row by -4 and add it to the third row. So we're going to have -4 plus 4, which gives us 0. We have -8 plus 5, which leaves us with a -3. We're going to have -16 plus 4, which leaves us with a -12. And last but not least, we're going to have a +32 minus 11, which leaves us with 21. Okie dokie. So we have simplified that first column. And now notice, looking at the resulting row 2 and row 3, we have scalar multiples. So what I'm going to do here is let's scale the second row by a factor of -1/3. And let's also go ahead here with the third row. Let's also scale this by a factor of -1/3. So this is going to leave us with the equivalent matrix. So again, that first row remains as it is. 1, 2, 4, -8. And now we have scaled our second row by a factor of -1/3. So this will become 0, 0, 1, -2. And now we want to go ahead and scale the third row by a factor of -1/3. So this becomes 0, 1, 4, -7. So smaller numbers are always easier to work with. Now notice here that the second row has what looks to be almost like a pivot in its third position, and the third row looks to have a pivot in its second position. So let's interchange those rows. So we are going to take the second row and interchange this with the third row. And so this leaves us with the equivalent matrix. First row still is 1, 2, 4, minus 8. The second row is now 0, 1, 4, minus 7. And our third row is now 0, 0, 1, minus 2. Okay, so hey, look at this. We have echelon form. Not row-reduced echelon form, but we're heading in the right direction. So let's continue row-reducing this to row-reduced echelon form. So we're moving to the second pivot position, and we want to use this pivot to eliminate the entry above it. So we will replace the first row by multiplying this second row by -2 and adding it to the first row to attain the new and reduced first row. So what is this going to leave us with? So giving ourselves plenty of room. So we have 0 plus 1 is 1. You have -2 plus 2 is 0. We have -8 plus 4 is -4. And then we have 14 minus 8, which leaves us with 6. And then the other two rows remain as they are. 0, 1, 4 minus 7, 0, 0, 1, -2. Beautiful. So now our first column and our second column are good to go. And we move to our third and final pivot position. And we want to use this third pivot position to eliminate the entries above it. So again, we're going to need to do this in 2 steps. So we'll need to do 4 times the third row plus the first row to attain the new and reduced first row. And then we'll also need to go ahead and do -4 times the third row plus the second row to attain the new and reduced second row. So here we go. This is going to be equivalent to, so we have, let's see, we're reducing that first row first. We have 0 plus 1 is 1. Oops. We have 0 plus 0 is 0. And now we have 4 minus 4 is 0. And last but not least, we have -8 plus 6 is -2. So we have that simplified first row. And now we want to do the same thing with the second row. So we have 0 plus 0 is 0. We have 0 plus 1 is 1. We have -4 plus 4, which is 0. And last but not least, we have +8 minus 7, which leaves us with 1. And the third row remains as it is, 0, 0, 1, -2. And we're excited here. We see, hey, this is the identity matrix in 3 dimensions. Right? We have pivots that are 1s, our leading entries along the main diagonal, 0 entries everywhere else. So what is this telling us? This tells us that x sub 1 is -2, that x sub 2 is +1, and that x sub 3 is -2. So we have one unique solution. So our general solution in its parametric vector form, or its vector form here, is the unique solution, x sub 1, x sub 2, x sub 3, where x sub 1 is -2, x sub 2 is 1, and x sub 3 is -2. And so this is our beautiful final answer.